So any questions left over from that sheet we did? Anything? Okay. So the first thing, we've already done a few of these, of course. This is U sub. This is the first thing, getting away from just straight anti-differentiation, like being able to link it directly to something that's a derivative. It's a little bit off. There's a little bit of something you have to account for. It really just makes it look better. It makes the form easier to tell what it is. So for example, if I had, let's do one related to what we were just doing. If I had 2x plus 1 over x squared plus x plus 7, do you notice how, can you factor the bottom nicely? No. You could factor it, maybe, if I forced you to. Some of you guys don't even know you could. Because you could use quadratic formula shows the intercepts, then you make it x minus each of those x-intercepts, and that would be remarkably disgusting. I don't want to do partial fractions with radical 5 plus 2 over 7. No, whatever the shit that would be. So before you start trying to do partial fractions or whatever, you first rule out that it isn't a chain rule idea. So is there a function in there whose derivative is in there also? And I want to be a little more careful with the way I say this. The derivative has to be free to go with the dx. That's huge. There's mistakes you can make by thinking you have it and you don't. So we'll do some problems where there's mistakes that you can make. This one's very straightforward. What is the derivative of this? Which is exactly that. So if I let, some of you guys might realize you don't have to do this, just to get used to the u sub. If I let u equal that, x squared plus x plus 7, then what's du? 2x plus 1 dx. That's the differential thing. And really, to be honest, it would be du over dx equals 2x plus 1. We're just multiplying the dx up. So that makes integral dx become integral du. The variable in here needs to match with that variable there, or else it's exceptionally freaky. All right, so what do I get here? I get integral 2x plus 1 dx is du, and that's 1 over u. That looks kick-ass. All right, so then this becomes, of course, natural log of
Absolute value.
good plus c, and then you just bring back in what u is. And it was x squared plus x plus 7. Bam, plus c. Schwa. All right, let's try some more. That's a little more freaky. So what if I had this here? What, Jeff? I don't know yet. Make sure you really see what this is. Right. So it's x times the cube root of 4 minus x squared dx. So again, it sometimes isn't this, but it almost always is. There's an inside function that's stuck somewhere, but its derivative is out, able to move around. So obviously, what's the inside function here? 4 minus x squared. Its derivative is negative 2x. There's an x right there. See, so the constant doesn't matter worth shit, because I can always make that work. If I'm missing an x piece, I can't make that work. How do I, so what do I'm,
Did you put a negative 2 on the outside?
there's a, yeah, beautiful. That's what I want you to do. There's a really dumbass way that some teachers show students. and I'm just going to be completely blunt. I don't think this is a shocker. If you've ever taken a little calc before and anybody does something like this, they need to re-examine their life as a teacher. Negative 2x dx, and then you solve for dx. Okay, that's complete, utter bullshit. And I know it works, but it works too well. So they're like overworks. It makes you think that certain things will work that wouldn't. And then you make all kinds of stupid-ass mistakes. So I have no idea if anybody's ever seen any calculus got to this point before. I'm not sure if you want to, yeah, I did, I'm here again. I don't know if you want to own up to it. Maybe took some in high school, you know. I don't know. But don't solve this for dx. I mean, do you understand what I mean by, if this x was not there, would you sub work? No. But if you're taught to just solve for dx, you're going to just start throwing shit in there and not give any thought to that. The most important thing. So the better way to look at it is to say, all right, I got my x dx. That's covered. I just need a constant. That's easy. Like somebody told me, how do you get a negative 2 to show up here? Well, you better at the same time put negative 1/2 out there. So overall, you just didn't do anything. Yay. I just made it look different. And the way it looks now is beautiful. Because now I can say, I can rewrite this as negative 1/2 integral. What is negative 2x dx? du. And this is the cube root of u. Poor little thing is dying. Are you working? Sort of. And of course, I can rewrite that inside as u to the 1/3, make it look a little bit better. And what's that integral? What's the integral of u to the 1/3? U to the, yeah. So that goes up by a power, and then I divide by the power, meaning multiply by the reciprocal. And of course, you don't stop there. That's where I could be an asshole. I didn't ask you about you, I asked you about for dx. And so then the last thing is negative 1/2. Well, here, let's be smart about it. Negative 3/8. What was u? 4 minus x squared. To the 4/3 plus c. If you want to put it back into root form, you can. It's starting root form, but it doesn't matter. You should have never invented root form of anything. I don't know if I've ranted to you about that. I ranted to my algebra class about that. Okay. Yeah, dude. That's one of your many rants. Sorry. Do you see how this captures the form? There's a lot of little detail shit that's unimportant for the first step. The thing in here has its derivative outside. That's exactly what this thing says. There's a thing in here whose derivative is out there. That is exactly what that says. That's when u sub works. All right. We already did one freak example. Ln is always a little freaky because its derivative is 1 over x. So you can have like an over x piece somewhere and an ln somewhere. You want to u equal ln, bam, bam, bam. Bam, bam, bam. Let me show you, let's see, what else, what other type do I want to show you? Make sure I show, yeah, maybe. So what about this here? Think about that. I should make this up somewhere else. Let me give you one while I'm thinking about another one. another example. Okay, good. Green, I think green sucks. Let's see. Try green. All right. So, what are you gonna let U be? Yeah. So there's definitely something stuck inside of somebody else. So I'm gonna try, before I try any other freaky things, I'm gonna try this. I don't know, screen acceptable. Oh yeah. So then du is gonna be just, yeah, I love it. So some of you guys have picked up on this crazy fact. It'll be 1 over 4x times 4, so the 4's cancel. So ln ax derivative is 1 over x. Really quick side note. Somebody was out talking to me after last class about this. Do you remember ln 4x? Can't you rewrite that as ln 4 plus ln x? So won't the derivative of this be 0? So any constant multiplier of x inside, you could pull it apart and make it just go 0. It's just a y-intercept piece, really. In this case, not really, because it won't be a y-intercept, but screw. So now, so I need 1 over x. I currently have that, but I can take care of that real easy. And if I could do this shit, I should be able, I could put numbers in, I could take numbers out. There's no balance that I got to do. I just got to get rid of the stupid 7. So what am I going to take out of here? 1 over 7. I like it. So I can rewrite this as 1 over 7. Let me rewrite this again. Get out of 7. You're out. So now I can have, I have 1/7 integral sine of u 1 over x dx is du. So then I get 1/7. Good. Negative cosine u plus c. So that becomes negative 1/7 cosine of natural log of 4x plus c. Ooh, I like it. Maybe not green. Okay. All right, let's do one more, and then I'm going to let you try some problems out on your own. Let me do, well, that. 2 different ways you can do this. I'm going to make that more interesting, Jeff. Oh, definitely. Now, hopefully, well, let's see. What are you guys doing for this problem?
Separate the W2 thirds.
Yeah, u. Now, you could technically use u sub on this. Because if you let u be w to the 1/3 minus 1, what's du? One-third? And do you see this is in there? Right? But there's nothing wrong with breaking this up, obviously. But real quick, let's see where this would go to. So I need a 1/3. So what would I put out front to get a 1/3 inside? Yeah, put a 3 so I can get a 1/3 inside. Just bear with me. Totally could do this all day long. But let's just see what this does. So this would be 3 integral. U is the top. 1/3 this dw is du. So then I get 3. What's the integral of u? What's the integral of u? Yeah, so the 3/2 u squared plus c, and what was u? W 1/3 minus 1. Now let's see what you get if you do it the other way, and plus c. I want this. This is interesting. I want to show you what happens here. Okay. Now, hopefully, most of you guys didn't do it that way. That would be kind of nice, because the much more direct way to do this is to just take this and rewrite it as what? So one way is this way. What's the slightly better way to do it? Yeah. Or because, like, the way I just told you, man. So if I wrote this instead, what happens here? You get w to the negative 1/3 minus w to the negative 2/3. So you get w to the up by 1, so it becomes negative 1 plus 3 is 2/3, so that's 3/2 in front, minus, this goes up to w to the negative 2 plus 3, 1/3. I'm just adding 1 to the powers, right? Every power works like that except for negative 1 power, and that's got its own thing, ln, so he's fine. Multiply by the reciprocal of that. Now, are those the same? Sure. If we FOIL this thing out, I'll get 3/2 w to the 2/3 minus 2 w to the 1/3 plus 1 plus c. I'll get 3/2 w to the 2/3, check, minus 3 w to 1/3, check, plus 3/2 plus c. Technically, they're not the same. But what's really going on is these aren't the same. I really want this. What is c? A constant. So what if the constant had to be 5/2? So here, that would be 5/2. Here, c would be 1, because that would make this 5/2. I really want you to understand. Every way I do this interval, if it's legal, it has to come out to be the same answer. Well, every answer is the same if it's off by a number, because they're all going to have stupid plus c on them. So you can totally be off by a number. You can just suck this in and make a new, you may call it C1. What's 3/2 plus a constant? Some constant. Right? Really, you guys kind of get that. So if you have a different approach and you think your answer is different, if you're checking it in the solution manual or whatever, if you have an extra constant there because of some way you decided to do it, you're not wrong. You can just roll it into one constant then. Does that make sense? I like it. That is a constant. You can just suck things into it. Everything's great. Okay, I like it. It's related to, if I said integrate this, I would hope to God that, I mean, how do you integrate that? The inside function, linear slope of 1, it's the same as x cubed then. So it'll be x plus 1 to the
4.
fourth, all over 4. Now, if you multiply this out first and then integrate each piece, you're not going to get the same answer I did. We'll be off by a constant, therefore we're not really different. It just gets rolled into the constant. It's just, it looks different because of the way I chose to do it. If you're crazy and you decide to multiply this out, okay, hopefully you know Pascal's triangle, that'll make it a little quicker. You guys know Pascal's triangle? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. It's the coefficients of, if you multiply this out, it's the coefficients of the result. Blah, 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 blah. You should really look it up. Right. But there's a lot of times when you don't need that shit, just leave it alone. Oh, good. Okay. That was my other point. Sweet. All right. So, I think we're ready. Yes. I don't want to say anything about one of the problems on there. So on the back of your partial fractions, you see U-sub problems. I have a little example at the top there. Do part A, and then we got to talk about part B. But if you look at part B, if you get done with part A, you can look at part B, see if it makes sense. Part A, D is an interesting problem. The rest of them are fine. Part A, D could freak you out.